All right, let's jump straight into this explainer. Today, we're going to demystify the invisible forces that literally dictate how everyday products are built and delivered to your doorstep. Have you ever actually stopped to think about how a factory operates? I mean, not the physical machines, but the underlying logic that tells those machines to turn on in the first place? Well, we are going to explore two absolutely fascinating supply chain philosophies: push and pull manufacturing.
So here's the ultimate supply chain dilemma. We have to decide exactly what triggers the creation and the movement of goods. Think about it. When workers clock in for their shift, how do they know whether to make 50 units of a product or 5,000? The answer comes down to how an organization manages its flow of materials, its production schedule, and its inventory. It all hinges on that one thing, the trigger. Here's our roadmap for today. Number 1, the triggers of production. Number 2, we'll look at push by visiting a custom furniture workshop. Number 3, we'll explore pull on a smartphone assembly line. 4, we'll talk about the power of visual signals. And 5, we'll wrap up with a push-pull hybrid model. Okay, let's kick things off with section 1, the triggers of production. This right here is the whole ballgame. It boils down to relying on forecasts versus reacting to actual real-time customer demand. In a pure push system, everything is totally forecast-driven. A central supply authority dictates exactly how much inventory to send and when, essentially pushing it down the chain. But in a pure pull system, it is entirely demand-driven. Production and inventory replenishment are strictly triggered by an actual request from downstream. Like a customer actually buying a product. Every party in the supply chain acts autonomously.
Moving right along to section 2, let's look at the push model in action with a custom furniture workshop. Picture a custom furniture workshop. This is your classic setup for low-volume, high-variety batch production. Here, production relies heavily on an MRP system. That stands for Material Requirements Planning. Instead of waiting around for you to order a chair, planners use forecasts to create these incredibly detailed time-phase schedules. Once a batch of, say, chair legs finishes one step, it is literally pushed to the next station based on that predetermined schedule. And the ultimate goal? Maximize capacity utilization. They want those saws and sanders running nonstop based on what they think they'll sell.
But, and this is a massive but, relying entirely on forecasts has some pretty major drawbacks. Push systems are notoriously vulnerable to the bullwhip effect. That's where a tiny little ripple in downstream customer demand turns into a massive disruptive tsunami of supply fluctuations way further upstream. Plus, if your forecast misses the mark, customer service completely tanks. And on the factory floor, pushing batches based on sheer guesswork leads to this massive buildup of excess work-in-process inventory. You end up tripping over piles of half-finished furniture that's just sitting there, waiting for the next machine.
All right, part 3. Let's pivot to a completely different world. A pull system on a high-speed smartphone assembly line.
Now, in this high-speed, continuous flow environment, the production rate is specifically matched to something called takt time. Takt time is this foundational concept from lean manufacturing that represents the exact pace of customer demand. So, the absolute crucial point here is that parts aren't made until there is an actual downstream request. Instead of trying to max out machine utilization by just building as much stuff as possible, like we saw with the furniture workshop, this pull system uses rate-based scheduling to perfectly match what is actually being sold right now.
As you can see, the goals here are entirely different from the push model. A pull system focuses on leveling demand to really smooth out the overall workflow. It aims to move materials quickly, completely eliminate waste, and operate with the absolute bare minimum amount of inventory. You are definitely not going to see piles of half-finished smartphones sitting around. You're maximizing the velocity of raw materials turning into finished goods rather than just worrying about optimizing machine usage.
Let's dive into section 4, the power of visual signals. Now, you might be wondering, without a central schedule barking orders, how on earth do these stations know when to actually do the work? Well, that brings us to a core tenet of lean and the pull model, using autonomous visual cues instead of top-down forecasting. The golden rule here, and it's a big one, is that material is not issued or produced until a specific signal comes from the user. But what does that signal actually look like in real life? In a lean environment, the go-to signaling tool is a Kanban system, and honestly, it's brilliant because it works entirely backward. Step 1, the downstream pacemaker operation, say the station attaching the screen to the phone, needs more screens. Step 2, a Kanban card travels backward down the line to visually signal the upstream process. And step 3, that upstream process produces exactly what was taken and absolutely nothing more.
This signal literally travels backward, step by step, to perfectly link upstream supply directly with downstream actual demand. It's just incredibly efficient.
And finally, Section 5, the push-pull hybrid models.
So push has its forecasting strengths for generic parts, and pull is obviously the undisputed king of lean efficiency. So which one is better? Actually, in the real world, modern organizations rarely stick exclusively to just one method. They combine them. During the push phase, a company might manufacture standard generic components based on long-term forecasts using a centralized schedule, and then push them into inventory. But then they flip the script. The final, customized assembly enters a pull phase, and that is strictly triggered by an actual customer order utilizing those autonomous visual signals we just talked about.
That specific moment of transition, it has a name. It's called the decoupling point. This is the exact push-pull frontier in the supply chain, where the system shifts from forecast-based pushing to demand-based pulling. By establishing this decoupling point, a factory can seamlessly merge the predictable, steady stability of batch processing for basic parts with the waste-eliminating, lightning-fast efficiency of continuous flow for the final product. So we've seen how the push model builds based on predictions, risking that crazy excess inventory, while the pull model waits for a signal, optimizing efficiency but requiring really tight synchronization. By combining them, modern supply chains try to get the absolute best of both worlds. So the next time you order a customized item, maybe a new laptop or a cool piece of furniture, ask yourself, at what exact moment did the factory stop guessing based on a forecast and start listening directly to you?